The time value of money is a core principle of finance. A sum of money in the hands has greater value than the sum of money to be paid in the future value. Discounting technique. So in order to find the present value, you are going to implement the discounting technique. Future value for n years is equals to P into 1 plus R whole to the power of n. So P stands for principal amount, R stands for rate of interest, and n stands for number of years. Hello students, how are you all? I hope you are doing good. So I welcome you to the financial management session. So in today's class, we are going to discuss about the second unit, that is time value of money. So we are going to calculate the future value and present value of cash flows. So before I move on to the session, so let me give my brief introduction. I'm Vaishnavi, Faculty of Commerce from Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So we'll see today's agenda. So we are going to start with the introduction part, that is time value of money, what is the concept, so why we are studying it, all those we are going to learn in the introduction part. Second, we are going to learn about the techniques of time value of money. Next, we are going to learn about what is future value, calculation of future value, and what is present value and calculation of the present value. So we'll straight away move with the introduction of the time value of money. The time, you know that so the time that was there right now will not be the same in the future. Correct? So in the same way, the money that is there currently right now, the value of the money will not be the same in the future. It might increase or decrease based upon the period that you have invested for, or depend upon the rate of interest that you are going to invest in for. So the concept of understanding the present value of the money as well as the future value of the money is all about the time value of money. So I'll start with the introduction part. The time value of money is the concept that a sum of money is worth more now than the same sum will be at the future date due to its earning potential in term. Okay, that means like I have told, so the value of the money which is there right now in the current period will be having more worth while comparing to the value that you are going to get in the future. So the time value of money is a core principle of finance. A sum of money in the hands has greater value than the sum of money to be paid in the future value. The same concept that I can tell, the sum of the value or the sum of the money that you are having right now is having the greater value while comparing to the sum of the money that you are going to pay in the future. The time value of money is also referred to as a present discounted value. So this is a basic introduction. So techniques of the time value of money. So we are going to implement two types of techniques. One is compounding technique and another one is discounting technique. So I'll give you a brief explanation about the compounding technique. Okay. So compounding technique, like it's the same concept called compound interest concept. Okay. The concept of compound interest is what? Calculating the interest on the interest amount. Okay. Like say for example, you have got 5,000 rupees in your bank account. So you have kept the 5,000 rupees in your bank account for a period of 1 year. Okay. So based on that, you are going to get the interest on it. So say for example, you are going to get some 10% interest on it. So now your interest will be for 1 year is 500. Now your bank balance will be 5,000 plus 500 will get 5,500. Now, the same amount will be continued for another year. Now, the interest will be calculated on not the principal amount, but the actual present value that is there in the bank account, that is 5,500. So, on that, if you're going to calculate 10%, you're going to get 550 rupees. Then again, if you're going to add it to the current bank balance, then your bank balance will be 6,050 rupees. So this is the concept of compound interest. So in order to find the future value, we are going to use a technique called compounding technique. So that means we're going to calculate the compound interest on the interest amount so that we can find the end maturity future value. Whereas in case of discounting technique, so in order to find the present value, you are going to implement the discounting technique. So that means your future value will be given. Say for example, in future, you are going to get 6,000 rupees. But you need to find out what is the present value of the money that is there you're going to invest right now. So in order to calculate that, you need to adopt a discounting technique. So in order to get the present value of money, these two are the important concept in the time value of money. So we'll start with the compounding technique. So as I've told, this refers to a method used to find out the future value of the present investment. So it includes a process of earning interest on both the principal as well as the accrued interest by reinvesting the entire amount to earn more revenue in the form of an interest. So the compound interest has been calculated on both principal amount as well as the accrued interest amount in order to get the more value or more money at the end of the maturity period. So the method of calculating the future value is having a future value of a single cash flow and annuity future value. So we'll see first one, future value of a single cash flow. That means, say for example, you have invested 5,000 rupees in the bank account. After that, you are not going to deposit any amount in your bank account. So this one is called single flow. So every year if you are going to invest 5,000, then that is the other concept. So we'll discuss about it in the coming slides. So single flow cash flow is what? Once you have deposited into the bank account and then nothing, you're not going to deposit any amount in the account or in the investment policy. Okay, so the future value of a single cash flow arising after a year is calculated in the base of a simple interest method. So this is the formula. Future value for n years is equals to P into 1 plus R whole to the power of n. So P stands for principal amount, R stands for rate of interest, and N stands for number of years. So the first problem here, Mr. A has deposited 10,000 rupees in a bank which is paying 12% rate of interest on a 8-year fixed deposit. Okay, so Mr. A, he has deposited 10,000 rupees in a bank account which is paying an interest of 12% for a period of 8 years. How much would be the deposit grow at the end of the 8 years? So the person have invested 10,000 rupees in the bank account with the interest of 12% and the maturity year or maturity period is 8 years. So with the help of the formula, we can find the future value that we are going to get after 8 years. So given 10P will be 10,000 rupees, R, so I have taken into the decimal, that is 0.12, n is equals to 8. So the formula, by implementing the same formula, future value is equals to P into 1 plus R whole to the power of n. So future value is equals to 10,000 into 1 plus 0.12 whole to the power of 8. So 10,000 into 1.12 whole to the power of 8. So we'll get 1.12 whole to the power of 8 is 2.476. So 10,000 into 2.476, they are going to get 12,476 rupees after 8 years. So this is how you calculate the future value. So second question. So Mr. X deposits 26,590 in a bank which is paying 10% rate of interest on a 15-year deposit. So how much could the deposit grow at the end of the 15 years? So we'll calculate it. So first P is equals to 0.590, R is equals to 0.10, then N is equals to 15. So future value is equals to P into 1 plus R whole to the power of N. So 26,590 into 1 plus 0.10 whole to the power of 15. So 26,590 into 1.10 whole to the power of 15. So 26,590. So 4.177. If you calculate with 26,590, we'll get total of 1,10,939. This is the future value. So P into 1 plus R whole to the power of N, 26,590 into 1 plus 0.10 whole to the power of 15. 26,590 into 1 plus 10, that is 1 plus 10 is, we'll get 1.10 whole to the power of 15. The value of 1.10 whole to the power of 15 is 4.177. So we'll get 1,10,939 as the future value if Mr. X has deposited 26,590 for a period of 15 years. This is the solution. So next we are going to calculate about the compounding techniques. So sometimes what happens, the compound interest might not be, will be calculated on the annual basis. It will be calculated on semi-annually or quarterly. So for that we are going to calculate the compounding interest. So this is the formula. So we'll straight away move with the question. So calculate the compounded value when rupees 10,000 is invested for 4 years and the interest on is compounded at 10% per annum semi-annually. Okay, so calculate the compounded value, future value of the investment, that is 10,000 rupees. It is invested for 4 years and the interest of it is compounded 10% per annum semi-annually. In a sense, it has been calculated for per year 2 times. So given P is equals to 10,000, R is equals to 0.10, N is equals to 4 years, M is equals to 2 times. So we are going to substitute in the formula. So P into 1 plus R divided by M whole to the power of M into N. So 10,000 into 1 plus 0.10 divided by 2 whole to the power of 2 into 4. So we'll get 10,000 into 1 plus 0.05 whole to the power of 8. So 10,000 into 1.05 whole to the power of 8. So 10,000 will get 1.477. So the total value is 14,770. So next question, calculate the compounded value when rupees 5,000 is invested for 5 years at 12% interest per annum. Interest is compounded on quarterly basis. So given P is equals to 5,000, N is equals to 5, R is equals to 0.12, M is equals to 4 times, N is equals to 5. So quarterly basis, in a sense, it has been calculated, or the interest has been calculated for 3 months once. So 3 months once for an year. So it has been calculated for 4 times. So we'll take the same formula. So future value is equals to P into 1 plus R divided by M whole to the power of M into N. So P, we have got 5,000 into 1 plus R is 0.12 divided by M is for how many times we are calculating? 4 times. Divide by 4 whole to the power of 4 into, for how many years the investment is been made? It's made for 5 years. So that equals to 5,000 into 1 plus 0.12 divided by 4 whole to the power of 20. So 5,000 into, so 1 plus 0.12 divided by 4 whole to the power of 20. So 5,000 into 1 plus 0.03 will get 1.03 whole to the power of 20. So 5,000 into 1.806. Future value of 9,030 rupees. So this is the future value. Next question, multiple compounding techniques we are going to do with the next question. So X invests rupees 10,000 in a deposit scheme in a public company. The rate of interest is 10% per annum. Interest is compounded half yearly. The duration of the deposit is 3 years. So you are required to find out the compounded value of the deposit on the maturity. So X is going to invest rupees 10,000 in a deposit scheme. So in a public company, the rate of interest is 10% per annum. The interest has been calculated of half yearly for every 6 months. So that means M will be 2 times. So you are required to calculate the compounded value for a maturity period of 3 years. So given P is equals to 10,000, R is equals to 0.10, N is equals to 3, then M is equals to 2. So future value is equals to P into 1 plus R divided by M whole to the power of M into N. So the present value is 10,000 into 1 plus R is 0.10. So M is, it has been calculated semi-annually, that means 2 times. So 2 divided by 2 into, for how many years it has been calculated? For 3 years. So 2 into 3. So 10,000 into 1 plus 0.10 divided by 2. So we'll get 0.05 whole to the power of 2 into 3 is 6. So 10,000 into 1.05 whole to the power of 6. So 10,000 into 1.05 whole to the power of 6 will get 1.3400. If we calculate with 10,000, so we'll get 1,34,000. So the future value is 1,34,000. So next we are going to calculate the future value of a series of cash flow. Series of cash flow in a sense, for every year the person is going to deposit some lump sum amount into the investment option. So that is called series of cash flow. The formula future value is equals to A into 1 plus R whole to the power of n minus 1 plus A into 1 plus R whole to the power of n minus 2 plus A into 1 plus R whole to the power of n minus 3 and to the total n years. So first question, Mr. X deposits rupees 1,000, 1,500, 2,000, 2,500 and 3,000 in a savings bank account at the end of each year. Calculate the compounded value at the end of 5th year when the interest is being charged as 8% per annum. So we need to calculate the future value if the person has been invested 1,000, 1,500, 2,000, 2,500 and 3,000 into a savings bank account for a period of 5 years, and we are going to calculate how much the future value that we are going to get at the end of the maturity period. So the question is that, so you can understand the question, so you can understand the answer as well. So first end of the year, so I have taken 5 years here. So it has been amount deposited 1,000, 1,500, 2,000, 2,500, 3,000. So number of compounded at 8%. So if the 1,000 is been deposited the first year, so remaining there will be 4 years left. So in the same way, 3 years left, 2 years left, 1 year left and 0. That's the last year. So compounded interest factor from table that I have taken from the table, okay. So you can refer it into the Google, or you can refer or take any textbook and you can find out the compounded interest factor. So the factor for first year is 1.360, then 1.260, 1.166, 1.080 and then 1. Okay, so the future value is been calculated as amounted deposited 1,000 into 1.360 will get 1,360. 1,500 into 1.260 will get 1,890. 2,000 into 1.166 will get 2,332. 2,500 into 1.080 will get 2,700. 3,000 into 1 will get 3,000. So if we add all this, so 11,282 is the future value that we are going to get after the 5th year. So this is one way of calculating the problem. There's another way, alternative method. So future value that I've taken the same equation. So future value is equals to 10,000 into 1 plus 0.08 whole to the power of 5 minus 1. So 1,500 into 1 plus 0.08 whole to the power of 5 minus 2. So like that, we are going to calculate till the 5th year. So next step, so I have taken 1,000, 1.08 whole to the power of 5, 1.08 whole to the power of 3, 1.08 whole to the power of 4, then 1.08 whole to the power of 1. So we'll get 1.306. Then we'll get 1,500 into 1.08 whole to the power of 3. The total answer is 1,888, 2,333, 2,700 and then 300. So overall we are going to get 11,282. So this is an alternative method. So if you don't have any table with you, so this is the alternative method you can adopt for. So next question. So Mr. X invests rupees 5,000 at the end of first year, then rupees 6,800 at the end of second year, and rupees 9,400 at the end of third year, and rupees 10,800 at the end of fourth year at an interest rate of 10% per annum. Calculate the future value of the investment at the end of the fourth year compounded annually. So this is the formula. So A into whole to the power of 1 plus R whole to the power of 4 minus 1, 1 plus R whole to the power of 4 minus 2, 1 plus R whole to the power of 4 minus 3, and 1 plus R whole to the power of 4 minus 4. So we'll calculate solution. So first future value is equals to, for the first year they have deposited 5,000 rupees. 5,000 into 1 plus 0.10 whole to the power of 4 minus 1, plus for the second year the person have deposited 6,800. 6,800 into 1.10 whole to the power of 4 minus 2. Plus for the third year, the person has deposited 9,400. So 9,400 into, so 1 plus 0.10 whole to the power of 4 minus 3. Plus for the fourth year, the person has deposited 10,000. 10,000 into 1 plus 0.10 whole to the power of 4 minus 4. Yeah. So next we'll calculate 5,000 into 1.10 whole to the power of 4 minus 1 is 3. Plus 6,800 into 1.10 whole to the power of 4 minus 2 is 2. Plus 9,400 into 1.10 whole to the power of 4 minus 3 will get 1, plus 10,000 into 1.10 whole to the power of 0. So 5,000 into, so 1.10 whole to the power of 3 will get 1.331 plus 6,800 into 1.10 whole to the power of 2 will get 1.210 plus 9,400 into 1.10 whole to the power of 1 will get 1.10 plus 10,000 into 1. So 5,000 into 1.331. So we'll get 6,665 plus 6,800 into 1.210. So we'll get 8,228 plus 9,400 into 1.10 will get 10,340 plus 10,000 into 1 will get 10,000. So if we add all these, the future value will be 36,033. So this is how you calculate the future value. So present value of the money. So if you want to calculate or if you want to find out the present value of money, you need to adopt the discounting technique method. So the formula for calculating the present value is equals to future value into 1 divided by 1 plus r whole to the power of n. So the first question, Mr. A promises to give rupees 5,000 after 3 years. What is the present value of this amount if the interest rate is 10%? So future value is 5,000 rupees, r is 0.10, n is equals to 3. So by substituting all the values here, 5,000 into 1 divided by 1 plus 0.10 whole to the power of 3. So we'll get 5,000 into 1 divided by 1.10 whole to the power of 3. So 5,000 into 0.90 whole to the power of 3. 0.09 into whole to the power of 3 will get 0.7510. So the present value is 3,755. So next question, what is the present value of rupees 2,000 receivable in 5 years if the rate of interest is 10%? So given future value is 2,000 rupees, rate of interest is 0.10, n is equals to 5. So present value is equals to future value into 1 divided by 1 plus r whole to the power of n. So future value is 2,000 rupees divided by 1 plus, so r we have got 0.10 whole to the power of n is 5 years. So 2,000 into 1 divided by 1.10 whole to the power of 5. 2,000 into 1 divided by 1.10 will get 0.9090 whole to the power of 5. So 2,000 into 0.9090 whole to the power of 5 will get 0.6209. So 2,000 into 0.6209, the present value will be 1,242. So this is how we calculate the present value. So next, the same will be applicable like how we have calculated in the future value. The same will be applicable in the present value in case of the discounting period. So the formula is future value into 1 divided by 1 plus r divided by m whole to the power of m into n. So what is the present value of rupees 10,000 receivable after 5 years at 12% interest per annum when the interest is discounted quarterly? What is the present value if you are going to get the 10,000 rupees after 5 years at an interest of 12% per annum? The interest has been calculated quarterly. So quarterly in the sense 3 months once. So that means in a year we are going to calculate 4 times. So future value is equals to 10,000, R is equals to 0.12, N is 5 years, then M is equals to 4 times. So substituting the same here in the formula, future value 1 divided by 1 plus 0.12 divided by 4 whole the power of 4 into 1. So the future value we have got 10,000 rupees. So 1 divided by 1 plus 0.03 whole the power of 20. So then 1 divided by 1 plus 0. Whole the power of 20. So 10,000 into 1 divided by 1.03 we have got 0.9708. So 0.9708 whole the power of 20 will get 0.554. So 10,000 into 0.554 we are going to get 5,540. So the present value is 5,540 rupees. So next is present value of series of uneven cash flows. So that means if you are going to deposit the future value in an uneven series. So the formula will be A1 divided by 1 plus R whole the power of 1, A2 divided by 1 plus R whole the power of 3, A3 divided by 1 plus R whole the power of 3 and so on to the n number of years. First question, find out the present value of a series of cash flow that will occur over the next 5 years. 1 to 5 years we have got cash flow 1,000, 2,000, 3,000, 4,000, 5,000. This is the discounted fact that will be already given in the table. So for the first year is 0.909, second year 0.826, third year 0.751, fourth year 0.683, then fifth year 0.620. So the solution here, I have taken the 5 years cash flow we have taken, discounted factor that is already given in the question that I have taken, and present value, how to calculate it, cash flow into discounted factor. So 1000 into 0.909 will get 909, 2000 into 0.0826 will get 1652, 3000 into 0.751 will get 2253, 4000 into 0.683 will get 2732, 5000 into 0.620 will get 3100. So if you add all these, so we'll get 10,646 is the present value of the cash flow. There's another alternative method that I have told. The same formula I have taken here. So present value for 5 years is equals to 1000 divided by 1 plus 0.1 whole to the power of 1. So 2000 divided by 1 plus 0.1 whole to the power of 2, like that I have taken for 5 years. So then next 1000 divided by 1 plus 0.1 will get 1.1. So to the power of 1, 1.1 to the power of 2, 1.1 to the power of 3, to the power of 4 and to the power of 5. Next 1000 divided by 1.1 whole to the power of 1 is 1.10. 2000 divided by 1.1 whole to the power of 2 is 1.212. 1.1 whole to the power of 3 is 1.331. 1.1 whole to the power of 4 is 1.4641. Then 1.1 whole to the power of 5 is 1.6105. So if you divide it, we'll get 909, 1653, 2254, 2732, then 3105. If you add all, present value will be 10,653. So 10,653 is the total present value if you are going to invest 1,000, 2,000, 3,000, 4,000, 5,000 for a span of 5 years. So then you are going to get the present value of 10,653 rupees. This is how you calculate the present value. So if there is any uneven cash flows has been invested. In this today's session, we have learned about different calculations of future value, present value, how we have to calculate future value if you are having compounded interest, and how to calculate the present value in case of discounting period, in case of uneven cash flows and even cash flows. So these are important topics that you are going to get for the examination. So in the coming session, we are going to calculate the calculation of salvage value in case of present value as well as future value, and calculation of the annuity. These are also the important concepts that you need to learn for your examination point of view. So I'll meet you in the next session. Thank you so much.